Welcome back. We are now at the point in this chapter that we can now use our skills on SI prefixes, significant figures, and measurement calculations. We can now use those skills to solve problems that we call dimensional analysis problems. Dimensional analysis is just a fancy word to say that we're going to take one measurement and convert it into a different unit. And so doing that, going from one unit to another, involves conversion factors. Now, we use conversion factors all the time in daily life, saying that 12 is a dozen, saying that there's 12 inches in a foot, saying that a ream of paper is 500 sheets of paper. The conversion factors that we're going to use most commonly in this course, particularly in this chapter, are going to come from density, the density equation, as well as the SI prefixes that were shown in a previous slide. Okay? Those statements, those inequalities, can be written so that one unit cancels to leave the unit that you are looking for. So for example, regardless of what dimensional analysis problem you have, I always like to start dimensional analysis problems by writing down the number and unit that you're given. Give yourself some space to work the problem. Go ahead and write down the unit that you're looking for, and then you can use that as a guide to help you determine what conversion factor is necessary to go from given unit to desired unit. And that also helps you determine how to write that conversion factor, because you always want to have the given unit in the denominator and the desired unit in the numerator. So you're left with the desired unit for your answer. So when you put these in your calculator, and we're going to do several examples shortly, when you put these in your calculator, numbers that are in the numerator get multiplied. Numbers that are in the denominator get divided. So we're going to walk through these 5 problems. I encourage you to pause the video here and try them on your own and check your answers. But we're going to go ahead and mush on and do these. These are one-step problems where we're only going to need one conversion factor, one inequality to go from the given unit to the desired unit. We're going to do, in the next video, we'll do some 2-step dimensional analysis problems, and we'll do some in lecture and recitation as well. But starting with this first problem, how many feet in 13 miles? Well, I'm going to start this problem just as I said in the previous slide. I'm going to write down the number and unit that I was given. I'm given 13 miles. And notice that the abbreviation for miles, MI, it's not M. M is meters. So just be aware of that. So I wrote down the number and unit that I was given, gave myself some space to work the problem, I wrote down the unit that I'm looking for. So I need to go from miles to feet. And I know, whoops, I gave the answer away already. Whoops, I was supposed to get my pen here. So let me get my pen. I know, because it's easier if I do my pen here, at least we'll see. I know that in 1 mile, that's 1 mi, there is 5,000, hopefully my writing will get better, 5,280 feet. And how do I know that? Well, I got that from the conversion factors online. If you need to use, I would give you that conversion factor if you needed to use it for a quiz or exam, since it's not one I told you to memorize. But I will write it like this so I can see my mile units cancel. I'm left with feet in the numerator, which is what I'm looking for. So in my calculator, 13 times 5,280, and what spits out of your calculator is this number here, 68640. But we got to remember sig figs. Oh, those sig figs. And if you remember, when we multiply and divide, we care about total number of sig figs in the least precise measurement. You should also remember that in conversion factors, like the 5,280 feet, or with the SI prefixes, all conversion factors have infinite number of sig figs. So you can think about that 1 mile as being exactly 1. So 1.00000 infinity. Infinite number of sig figs. Similarly, the 5,280 feet, it has infinite number of sig figs as well. So if I have infinite number of sig figs here and only 2 sig figs here with the 13 miles, my final answer, when written with sig figs, can only have 2 digits. And so the best way to express this would be in scientific notation. So I'm going to do 6.9 times 10 to the 4. 10 to the 4 because I moved that implied decimal place over 1, 2, 3, 4. So that is the correct answer with sig figs for the first one. Let's mush on to the second. I'm given something in seconds. I need to go to nanoseconds. I see that, both have seconds in common. And I got to get to nano. So this, seeing that abbreviation N for nano, it's here as well, should tell you that, I'm going to have to use the Greek prefixes, the SI prefixes, to convert seconds to nanoseconds. And so I see that in 1 nanosecond, there is 10 to the negative, I can write this, 9. That's a negative 9 seconds. Negative 9 seconds. My second units cancel. And so when doing that division, you'll do 1.01 times 10 to the negative 8. If you want to multiply it by 1, you'll still just get the 1.01 times 10 to the negative 8. Then you need to divide by 10 to the negative 9. This has 3 significant figures. Conversion factors have infinite, so my final answer is 101 nanoseconds. Let's go on from kilograms to pounds. I need to go from kilograms to pounds. If you needed this conversion factor for a quiz or exam, I would give it to you because I don't know it off the top of my head either. But I bet if you're going to the medical field, I know nurses often go from kilograms to pounds. I know in 1 kg, and I put that in the denominator because I want my kg units to cancel. I have 2.204 pounds. Kilogram units cancel. Doing that multiplication, I'm going to have a total for my answer of 4 significant figures. So my final answer, 220.5. 2 more to go. Let's go from 8,944 millimeters, write down number and unit, and we're converting to meters. I see I've got meters in common. I've got that M prefix for milli, so I'm going to use that Greek prefix definition to do the conversion factor. My 1 millimeter will go in the denominator because that's the unit I need to cancel. In 1 millimeter, there is 10 to the negative 3 meters. Millimeter units cancel. Doing the multiplication with 4 sig figs as your final answer should give you 8.844. I'm sorry, 8.944. Sorry about that, guys. 8.944. Let's do the last one. So this is a unit that we'll encounter later in the course, angstrom. It's this hat with this A with a little funny little hat, funny little symbol on it. It's a German symbol. It's often used when talking about the diameter and radius of atoms and the size of molecules. So I think it's an important unit. It's one you're going to see often. But I will tell you that 1 angstrom is equal to 10 to the negative 10 meters, and I want you to convert that 0.7 angstroms into meters. And hopefully you say at this point, no problem. especially since I gave you the conversion factor, I know that that 1 angstrom, which will go in the denominator, is 10 to the negative 10 meters. Angstrom units cancel. I'm left with meters. Doing that multiplication gives me 7 times 10 to the negative 11 meters. So you should feel comfortable doing one-step dimensional analysis questions using the SI prefixes and also using conversion factors. If you needed something like feet and miles, I would give that to you, or kilograms and pounds. We will do many more examples on the recitation worksheet in lecture. In our next video, we're going to talk about taking this a step further, being able to do dimensional analysis questions where you need to involve more than one conversion factor to get to the final answer.